We cannot choose our external circumstances, but we can choose how we respond to them. Hello guys, welcome to lesson number 5 of Finance and Recursion. Now, today I have a decent amount of housekeeping to get through, so without further delay, let's get through that. Now, today's lesson 5, we're talking about the rule for the nth term in a sequence modeling geometric growth or decay. So geometric growth, no longer linear growth. We're looking at something that's either curved up or curved down. Our goal is to use a rule for the future value of a compound interest investment or loan, or a depreciating asset to solve practical problems. So we're looking at either compound interest or reducing balance depreciation. But first, I wanted to talk about a quick announcement on SACs and Tests. You guys will be notified on Compass a date where all of you, every single student in the cohort that's doing further maths, will be sitting the test or the SAC. So because we don't have any misalignment of our classes anymore if we're going remote, that means we can all do the SAC or the test at the same time. We will decide what platform you will do your SAC on. So for example, it might be on Teams, but that hasn't been decided yet. You guys will all be expected to use the same platform. So if you guys have any issues with that platform, you have to let us know as soon as you can. You'll also need to be present at that time that we designate. So if that's example on Teams at 11 a.m. on April 20th, then you must be online at that time. Otherwise, we're considering that you not being at the SAC. So if you contact us at an earlier date that there's an issue with that time, with the program that you're using, that's fine, but you have to let us know earlier. If there's issues on the day, you have to call the school or send an email to me as soon as you can. So you have to find out a way to be online at that time. So everyone will be online at the same time, doing the same SAC or the same test. Luckily, our SAC is pretty much open book. So we're saying that you're allowed a bound reference book. Essentially, that means open book. Now, when it comes to the exam, there is a specific way that we're talking about bound reference, but we'll decide whether or not that it is meant to be completely open book, or if you guys have to verify that you're using your bound reference and your bound reference only at the start of the SAC. So somehow we will figure that out. And there will be an upcoming video on what's in the SAC, so please stay tuned. Keep watching these videos. It really does make me, not worry when I see a lot of people watching the videos. So please stay on top of that. All right, now into some maths. So this question is from the 2009 exam, which is the year that I finished school. So I wasn't doing further maths at the time because I was in New South Wales, but from 2009. A new air conditioning unit was purchased for $5,000. So that's V0 on the 1st of January 2009. On the 1st of January of each year after 2009, its value is depreciated by 20%. So that means our R is 20%. Using the reducing balance method. The value of the air conditioner will be below 1,500 for the first time on 1st of January, which year? All right, you guys give it a go first, because this is the last lesson's content, and now I'll get into it. So there are various ways to do this. You might already be able to do things the quick way, but let's set up the recurrence relation. Vn plus 1 equals 0.8 times Vn. How did I get 0.8? Well, I know that R is equal to 1 minus R on 100, because we're talking about depreciation. And since it says 20% and reduced imbalance, I know that it's going to be in this format. If we look at our notes, we can see reducing balance depreciation recurrence relation is R times Vn, where capital R is 1 minus little r on 100. So we know it's going to be 0.8 times Vn. So what we want to do is we start with the starting value, and then we apply this multiplier, this 0.8 multiplier, until it's below $1,500. So we're looking for so we type in 5,000, we press enter, and then we press times 0.8. So this is going to be 2009 for 5,000, 2010, 2011, 2012, 2013. Oh, we're looking for 1,500. 2014, 2015 is when the first time that the value is below 1,500. So we're looking at 2015. The answer is D. So that's how you do those types of questions. If you're not sure about how to do this, please look at the previous lesson. A very similar question, same exam, 2009. In 2005, Peter's annual salary was $35,000. So this is V0. We're starting in 2005. At the start of each subsequent year, his annual salary increases by 4.75%. So R is 4.75. In 2010, his salary will be closest to. All right, let's set it up. V0 is 35,000. Vn plus 1 equals 1.0475 times Vn. How did I get 1.0475? Since we're talking about a percentage increase here, this is the same as compound interest. So we can essentially say that R is equal to 1 plus 4.75 all over 100, which is then equal to 1.0475. That's where I got the 1.0475 from. Now again, we need to go to our CAS. We're starting with 35,000, press enter, then we times 1.0475. And we're looking for in 2010. So we've already pressed enter once. So this was 2005, this is 2006, 2007, 2008, 2009, 2010, 44,140. So we're looking at, the answer is D again. Cool. All right, for those of you that love equations, we're looking at the rules for the nth term. So the rule for the nth term in a sequence for geometric growth or decay. For geo growth or decay, remember that V0 is the starting value and Vn plus 1 equals RVn. That was our recurrence relation. So this is our recurrence relation, this thing here. So the rule for the nth term, sorry, that's horrible. Let's try that line again. The rule for the nth term is given by Vn equals R to the power of n times V0, where R is 1 plus R over 100, and R is the per annum rate divided by the number of compounding periods. Remember this from last lesson? We were looking at, for example, if we had a 4.8% interest rate per annum, and we had it compounded monthly, then our R is equal to 4.8 divided by 12, which is 0.4. So we got to remember, number of compounding periods is important for determining little r. Now we also have to determine little n now. If we have a different compounding period to yearly, then n is the number of years times the number of compounding periods. Now all of this stuff should now be in your sheet of notes like this. So I'll give you some time to write that down. So you want that in your notes somewhere, and you should see that these two rules are the exact same for both geometric growth and geometric decay. The only difference is this 1 plus R over 100 and 1 minus R over 100. So that's the difference between compound interest and reducing balance depreciation for those things. All right, so we got our notes down. So, like I just said, the only difference is for compound interest, R is equal to 1 plus R over 100. And for reducing balance, R is equal to 1 minus little r over 100. Everything else is the same. Else is the same. All right, now a little bit of a side note. So I've talked to some of you already, and you've found, well, your feedback was from last year that Finance Solver was a bit of a pain in the butt. Here is a slide which defines each of the terms in Finance Solver. So please, if you're not so sure in Finance Solver, have this set of slides or this slide written down somewhere. So N is the number of interest periods. Remember, this is going to be the number of years times number of compounds per year, per annum. I is the nominal interest rate. So this is always in a whole number. So you'd write, for example, for 4.8%, you'd literally write 4.8 in here. PV is the principal, your starting value. Payment, this is 0 for compound interest. This is the amount that you're either adding to or subtracting from this finance equation that you're worrying about. So this is 0 for compound interest for today's lesson, but it won't always be 0. And when it changes is really important for later lessons. The future value is the total at the end of the period. So after you've invested a certain amount, your future value is how much you have at the end of 5 years, at the end of 10 years. Our P/Y is the payments per year. So if you're talking about quarterly compounding, then your payments per year is 4. If you're talking about monthly compounding, then your payments per year is 12, and so on. Daily compounding, your payments per year is 365. Now in further maths, these two are always the same, and your calculator will automatically make these both the same. So for further maths, these two numbers never are different. They're always going to be the same. If one's 4, then the other one's 4. Now, depending on the question, present value or future value are negative or positive. If money is flowing from you to the bank or to a lender, then that is called a negative cash flow. If money comes towards you, so that's good. We want money coming towards us. That is a positive cash flow. So that's how you determine whether the sign that you put into your CAS calculator for example, principal, payment, future value, that determines what sign that value will be. We'll do some examples. So a principal value of $10,000 is invested in an account earning compound interest at the rate of 9% per annum. The rule is given below: 1.09 times to the power of n times 10,000. Find the value of the investment after 4 years, correct to the nearest cent. Well, V4 equals 1.09 to the power of 4. Notice how instead of n here, we've written 4. Because we know after 4 years, we're going to have this to the power of 4 times 10,000, which is $14,115.82. Now, find the amount of interest earned after 4 years. So, amount of interest earned. So, this is the total value. The amount of interest is just this value minus the original value, the starting value. So interest is just the amount earned on top. Let's put some dollar signs here as well, because we are talking about money. Find the amount of interest earned in the 4th year, correct to the nearest cent. All right, I want you guys to think about this one. We want the amount of interest earned in the fourth year. So we figure out the total amount in the fourth year and we subtract it from the total amount in the third year. Now this change will give us the amount of interest. Now this will be 1.09 to the power of 4 times 10,000 minus 1.09 to the power of 3 times, sorry, I have to be a bit pedantic here, times 10,000. So think about why this gives us the amount of interest earned in the fourth year. We're talking about how much value is in the actual account at the end of 4 years, and then this part is talking about how much value is in the account after 3 years. Now the difference between those two values is going to give you how much interest was earned that year. So that's why this equation works for the fourth year. In this case, it is $1,165.53. All right, if the interest compounds monthly instead of yearly, write down a rule for the value of the investment after n months. So a rule, not a recurrence relation, a rule. So, and it's talking about monthly instead of yearly. So R in this case is going to be, well, 9% divided by 12, which is 0.75. And our R is going to be 1 plus 0.75 divided by 100, which is 1.0075. So our rule for the nth value is Vn equals 1.0075 times, what's our V0? 10,000. To the power of n times 10,000. Apologies. So that power of n is very important. Now, let's use this rule to find the value of the investment after 4 years. So that's 48 months. Right, so Vn equals, we know that we're trying to find the 48th month. So V48 equals 1.0075. Remember, this is our monthly compounding R. And then we want to find that to the power of 48 times 10,000. And this is $14,214.05. So that's the value after 4 years, knowing that we got given a monthly compounding period. All right, how long will it take 2,000 to amount to 3,500 at 8% per annum, compounding annually? All right, so when you see compounding annually, you're very happy. You don't have to do anything extra. You just do your basic, this is V0. We're trying to amount to 3,500, so we can write, this is our future value, so this is going to be Vn. Since Vn equals R to the power of n times V0, we're trying to find little n. Okay, so we're actually going to have to do this using our CAS. So we go into our calculator and we're starting with 2,000. We press enter, then we say times 1.08, because our little r is 8%. So 1.08, so that's 1, 2, 3. Okay, we're looking for 3,500. 4, 5, 6, 7. So after 8 years, it's taken 8 years for it to finally get over 3,500. So you'll say our answer here is after 8 years. Now, calculate the number of interest-bearing periods, n, required, and hence the time it'll take, 3,600, to amount to 5,100 at a rate of 7% per annum, interest compounding quarterly. Okay, so we're going to do this one actually a little bit different. We're going to use Finance Solver for this one. So let's write down all of our values. N is the number of compounding periods, and this is the thing that we're trying to find. So we leave a question mark there. Now, PV, our present value, is our starting value. So we're starting with 3,600. Payment is 0 for compound interest. We have no payment, no regular payment that we're doing. We're only worried about the interest. Our future value is equal to 5,100. Our rate, I forget the letter for rate, just bear with me. Menu, Finance Solver, I. So I should have written that up above, but that's okay. Our I is equal to 7% per annum. Our payments per year and our compounds per year, remember these are always going to be the same. Since it says quarterly, this is equal to 4. So let's pop all of this into Finance Solver. Our N is, we don't know, so we skip that one. Press tab. We know our I is 7%. Our present value is 3,600. Our payment is 0. Our future value is 5,100. Now, remember what I said about the signs being important, whether we have positives and negatives. Now, our present value, in this case, is the amount that we're giving to the bank, hoping that we get interest on that amount. So since we're giving this to the bank, this is a negative value. It leaves us. Money is going away from us. That's negative. So we have to write here, negative 3,600. Payments per year, 4. Compounds per year, 4. It should do that automatically. We want the payment at end. Just leave that. We never change that. And we're trying to find N. So when we're in this box, we press enter and it calculates it's 20.07. So that means our N equals 20.07 quarters. Now, remember, after 20 quarters, we haven't actually reached 5,100 yet, which means that it will take 21 quarters, which is the same as, or 1 year and 9 months to reach 5,100. So that's really important. Our N was 20.07, but remember we can only have a whole number of quarters. And after 20 quarters, we haven't reached the amount. But after 21, we have. So we have to round up to 21 in this case. All right, let's look at some reducing balance depreciation. The computer system is 9,500 to buy, decreases in value with reducing balance depreciation of 20% per year. A recurrence relation is shown below. Write down the rule for the value of the computer after n years. So we're given the recurrence relation, and you can see we've got V0 and we've got Vn plus 1. We're asked to find the rule, and our rule is going to look like this. Vn equals something. Now, our rule for reducing balance depreciation, we know it's going to be R times V0. Now, what's R? Well, we can actually find it from here. R is 0.8. And what's V0? Well, r to the power of n times v0. Our v0 is 9,500. So Vn is equal to 0.8 to the power of n times 9,500. So that's how we rewrite a recurrence relation into a rule. Use this rule to find the value of the computer after 8 years. Write your answer correct to the nearest cent. Alright, so we're looking at V8 equals 9,500 times 0.8 to the power of 8. Now if you type that into your calculator, you'll get something that looks like $1,593 and rounded to the nearest cent, $84. So notice as well that I swapped the order here. It doesn't matter which order you put it, as long as you've got the numbers. So here, this is R, that's N, this is R, this is V0. So that's where all these numbers come from. Calculate the total depreciation of the computer after 8 years. So what this is asking for is how much has this computer gone down in value? So we simply do 9,500, which is the starting value, minus the value after 8 years, and that gives us $7,906.16. So that's how much the computer has depreciated by. It's gone down by that much value in 8 years. All right, last one. A photocopier purchased for $8,000 depreciates by 25% per annum by the reducing balance method. If a photocopier has a scrap value of $1,200, how long will it be before this value is reached? So how long will it be? We're looking for a value for n. We've got 25% per annum, so per annum's good. We don't need to worry about changing this 25% to anything else. We'll be getting an answer in years. This is V0, our present value, and this is our future value. So V0 is also known as our present value, and this is our future value, how much it's going to be worth at the end. So let's set it all up. N is equal to question mark, we don't know. I is equal to negative 25%. So you don't need the percent here, so I'll actually get rid of that. Negative 25% because it's depreciating by that much. PV is 8,000. FV is 1,200. Compounds per year and payments per year is equal to 1. They're both equal to 1, and I forgot payment is equal to 0 because we're dealing with compound interest. We haven't got any regular payment yet. That's for future lessons. So if we put all this into solver, so we don't know what n is. We know I is minus 25. We know PV is 8,000. Now think, is this 8,000 a negative or a positive value? So because we purchased this $8,000 photocopier, this is going to be minus 8,000. So minus 8,000, the money left us at the start. Payment 0, future value is 1,200. That's positive 1,200 because we can sell it for $1,200 at the end. Payments per year is 1, and that should automatically change your compounds per year. Now we're trying to find n. So the value here is 6.59. So n equals 6.59. But remember, after 6 years, it hasn't reached this value yet. So this value is reached after 7 years. You have to round that one up because we haven't reached the value after 6 years. It's only after 7. Anyway, guys, so today's work is 5E, question 1 to 12. Please attempt as many questions as you can. Let me know any questions that you might have via email or on Teams. That's where I'll reply.